of his interest, and the title of the paper is Development of Dynamic Simulation and Modeling for Bio-P Removal. Yes, please.
بسم الله الرحمن الرحيم وجعلنا من الماء كل شيء حي. صدق الله العظيم. Ladies and gentlemen, distinguished attendees, thank you for the generous invitation from Prince Sultan Research Center and King Saud University. And our titled paper today is focused on the eutrophication phenomena which have been founded in the coastal area, especially in the important water courses like Red Sea and Arabian Gulf. And this paper was done by transferring German know-how techniques for using such updated methods which is focused on the instant response readings of the pollutants, and it's named a dynamic simulation. And due to the biological phosphorus removal importance for the wastewater, especially in domestic and industrial fields, and the adverse impact to the water courses, we are very interested in the field of removal of this phosphate, regardless the traditional methods of chemical precipitations. And our modeling have been reached a value less than 2 milligram per liter or 2 ppm, and this results is very impressive regarding the biological anaerobic treatment in the field of domestic wastewater treatment plants. At the literature review, we know very well that the phosphorus as an element is particularly toxic and is subject to bioaccumulation, and phosphorus is as a nutrient will enhance the growth of the algae and plume, especially in the aquatic life and for water courses. And some industrious intrusion we have been founded in the sanitary sewer system make such concentration from poultry farms or others like in fertilizers. And those intrusions have become a serious problem in coastal areas, especially in Saudi Arabia, like Jeddah city or in Dammam city. And also this contributing to the other sources like nitrate. So high phosphorus concentration associated with this accelerated eutrophication of waters is promoting the depleting of the DO in the aquatic, which required essentially for the aquatic life, and also will make some adverse impact to the environment and in the coastal area, which can be used for recreation and the other skills. And finally, our main concern is to preserve and to protect the aquatic ecosystem. So we are trying to facilitate such a modeling technique can be used for resorts and for all the area which have a point source or direct discharge in the to the sea or to lakes or to rivers or whatever, Gulf or other water courses. The main inorganic form which we are concerned with 70% from the total phosphorus, which is a phosphate as a PO4, and this can be easily removed if we will have such environment culture under usage of the phosphate accumulating organisms. So the technique was based, the mechanism based on anaerobic bacteria and how to promote those bacteria in a good environmental conditions, which is called Acinetobacter, and this is to break the fatty acid chains to soluble phosphate, which will make release, and those release stage will be followed by uptake under aerobic conditions, so the phosphate can be removed easily. And this is the stages which are required for process train to build any treatment plant based on conventional system. The first stage will be anaerobic, and it will take within 2 hours, and after the anaerobic phase followed by aerobic phase, we will find that all the substrate, will be decreased as a food for the microorganisms, and the phosphate will be uptake, so the final effluent from the treatment plant, you will find it will be decreased by about 95% from the total influent value. This is also the release and uptake under the anaerobic and aerobic conditions, and this is a chain which requires the fatty acids and what is the break for the compound on the phosphate within a biological flock, and how each biological flock which contains the microorganisms in suspension slurry or in suspension liquid can used as different stages of process train for aerobic and anoxic or anaerobic. On the same time, the ammonia will be oxidized, and also the form of nitrate will be converted and oxidized to nitrate in O3, which will be denitrified in the anoxic zone within the carbon source available. So also with the same time you can remove both major nutrients, phosphate, PO4 as a P, and nitrate in O3 as a nitrogen, so you will remove both of the major impacts adverse to the ecosystem. And this is the value of the substrate which can be used for removing the soluble phosphate, and based on the influence of the raw sewage, if the phosphate measured to the COD, the ratio CO2 or soluble readily COD, chemical oxygen demand, is higher than 42, so the anaerobic treatment will become more efficient as a biological treatment for removing the efficient. The thesis and the experimental work which have been done, it continues from the background of the biological researches have been done in Europe and in the States, and by using such a technique which will rely on only the soluble substrate, give us a new technique for pilot scale plants which can be built for such practical applications, and those practical applications will achieve the goals from removing the nitrate and phosphate concurrently in one process stage. And finally, we developed the mathematical modeling can be predict and to estimate the effluent quality of the phosphate for any treatment plant required to be designed for municipal or industrial applications. So no need to use the traditional methods or the other methods, and we can build and rely in such formula for sizing the units required for those stages. And this is the aim and the goal of our paper, is to develop very simple and very easy methods for producing, and can be used for any end user to build his own treatment plant without any sophisticated methods which have been used for chemical precipitation and the sludge problems happen from the chemicals which found traces in the sludge. So the stages which have been done in this thesis consisted of 4 stages. First, the intrinsic or inherent wastewater characteristics should be identified, and this is the main important issue, is to identify the real characteristics of the influent raw sewage which you need to build your treatment plant. The second one is to build a simple batch reactor like SPR or deep SPR, sequential batch reactor, and to use a simple test for identifying the optimum ratio of the phosphate removal. And finally, you can evaluate what are the results obtained, and for each zone, for example, for each country have different environmental conditions, so you can build your own technique in each country based on temperature, pH, and sludge ages and other environmental conditions and kinetics of the process. And finally, you can feed the mathematical electronic spreadsheet, which is a mathematical modeling, and you will size your treatment plant, and this will give you a good results in the operational based on the actual figures of the real and intrinsic wastewater characteristics. And if you have changes within the year, which we are calling seasonal variation in wastewater characteristics, we can also adopt such technique by dynamic simulation using SCADA system to promote the growth of the phosphorus accumulating organism, which can customize the variation in phosphate removal, or to be customized also with the substrate which is based on the soluble readily chemical oxygen demand. And we built 2 years experimental work in 2006 and 2007, and we have been calibrated the model in Germany, in Ruhr University, and used this method of COD instead of the traditional method of BOD. We can rely our input for this model with feasible results, because as you know that carbonaceous biological oxygen demand is not the major effect for removing phosphate, but the phosphorus accumulating organism is based on the soluble part of the COD. As you know very well, why we used COD or specifically soluble COD, because the soluble readily biodegradable fraction plays an important role for biological phosphorus removal, and this removing microorganism will become in relation with the substrate fatty acids coming with the raw sewage. This is a subdivision we founded in more than 120 samples within the last 2 years, 2006 and 2007, that the biodegradable COD is around 60 to 80%, and the part was used for removing the phosphorus as a phosphate or orthophosphate was found around 25% as an average value. How we will make this determination? By readily COD, if you will see here, this is the batch reactor biomass growth within the time of the simulation, within 24 hours. So you can find here the mixed liquor, volatile suspended solids, which mean the microorganisms, and the food, which means the substrates. And this is the seasonal variations for the soluble COD, which is measured chemically as a theoretical oxygen demand. And if you will see here, within the year of 2007, the maximum value of the concentration was found 690. It means that this is industrial intrusion, not municipal value. You know very well the municipal value not exceed about 250 milligram per liter. And if you will have higher values, it means that you have such strange sources intrude the system or the municipal sewers. Also, this is in the second year, and this is also the value of the substrate which we found. And if you will fractionalize the COD fractions based on those seasonal wastewater sampling, you will find that we have two groups. One group is A and one group is B, and you will find that the average value we can rely for theoretical oxygen demand or soluble biodegradable readily COD is around 377 ppm or 377 milligram per liter. So the ratio of this one was reached about 40%. It means if you have a certain value from your input data, you will find that 40% as an average value from this value can be utilized by the bacteria. So the 60% remaining part is not effective to be used for this bacteria or microorganisms concerning the phosphorus accumulating microorganisms. Also, this is the same group within group B the other year, and you will find here the average COD fractions, 42%. And based on this, you can define the phosphate as an influent total phosphate, which you can have a soluble phosphate PO4 around 80% as an average value, and the organic value, which is around 20% as an average value. Our main concern is the inorganic part, which means phosphorus as a PO4 or phosphate. The patch reactor methodology using the new German technique by OEM or original manufacturer is called the dynamic simulation. It means variational of characteristics and the customization of the kinetic of the process within the time, because as you know very well, there is a steady state which is fixed concentrations within the time, and if you have a variation within the year, you cannot adapt your treatment plant. So the dynamic simulation will give you the opportunity and the chance to customize your system from kinetics issue and to adapt and modify the system based on the variation of the influent characteristics of raw sewage. And this is the German know-how here, and this is the benefit of using a dynamic simulation, optimization of variation system, reducing the cost, reducing the power, and reduction of sludge. And this is the laboratory, and this is the online instrumentation by the supplier which you used. And this is the WinCC, which is software was used for process visualizations. And based on the cyclic, which we call the sequential patch reactor, the Euro simulation modeling, which have been adopted by WRC or other ATV in German, responsible for all the specs for the wastewater treatment and other municipal water. We relied for ASM2D, which is the COD degradation, and at the same time concurrently with nitrification, denitrification, and this is the model which gave good results for phosphorus removal. This is some HSG guidelines according to Germans' know-how, and this was very useful and suitable for the environment of the GCC, and can be run in the MENA or Middle East and North African, and it will give good results. As you see also here, this is the DIC SPR, and this is the stages cycling can be used by dynamic simulation, and within the time of the hours you will see the variation that you will have in the blue line, that you have trend of phosphate release, and then you will have after 2 hours phosphate uptake or absorption by the bacteria. This is similar models, and this is the results of some models and the maximum effluent values. And if you will go to see what is the model itself, if you like to build your own model and your own field in any institution that you can build a patch reactor. You will have 4 sensors for measuring DO, pH, COD, soluble. Now, very reliable instrumentation which is called online analyzer can give you instant response results, reliable, 95%. For the COD and for BOD and for NO3 and for ammonia and also for phosphate. And this is the process flow diagram for the process stages, which anaerobic stage, anoxic for denitrification or denitrifiers of the nitrate formed by the bacteria nitrifiers, and for the release of the phosphorus in anaerobic and uptake for the phosphate in the aerobic or oxic stage. And finally, we'll have the separation method, which is based on plain sedimentation or other membrane technology for separation. So you will have the effluent free of phosphorus. You should rely in composite sample within 24 hours to develop your own model. Don't rely in grab sample, so it's better to have a composite sample within 24 hours to give the real data. And if you will see here the actual curves for this monitor in 2007, that within anaerobic you have a release value. Suppose you have influent value 10 milligram per liter, after 2 hours you will have about 22. But when you will go in the anoxic stage, there is no variation in phosphate. After the anoxic stage, you will find the aerobic stage, which is the main stage required for remove the phosphate by what's called uptake or absorption of the phosphate. And you will find the efficiency for biological treatment efficiency reached 91. Conventional system in the Middle East, based on the last survey in 2005, was only 70% removal, and this is the optimum. Now, by this dynamic simulation technique, you can achieve up to 92% as a treatment efficiency value using such new technique. And it's very easy. And this is the same one also for such variations within the seasonal. And results for this modeling, we can go on the last stage, that you can, based on the how milligram phosphorus was removed per volatile, means that the concentration of phosphorus based on the concentration of the bacteria itself. And finally, if you like to build a mathematical model, you have to rely, and our background for mathematical model was coming from the Water Research Center. It is a British institute, and it gives some background about how to develop such a mathematical model for prediction of the effluent phosphate. Based on this, you will find that the model will use only readily biodegradable soluble COD, which can be converted to the volatile fatty acids, and this conversion is mediated by the non-BAO, and then all will become uptake by the released by the BAO, and then uptake in the anaerobic stage. And the rate of phosphorus released is stoichiometrically, if you will use it, those kinetics is a mass converter, what's called SPSI, or soluble biodegradable. So you can reach this formula easy, and we record this formula under Azayat 2008 because it is a record of 2 years of 2006 and 2007. So the main factors is COD, and exponentially use the time in anaerobic stage, and the sludge age is a major factors can govern the efficiency for removal. So the output of this model, it will give you the optimum ratio for phosphorus removal, and what is the best detention time or retention time which can size, because it means if you will have the detention time and you have the fluid, so you can size your volume or your reactor based on this stage. So you will optimize your civil works, your mechanical works, and also you will achieve the efficiency required for such application after commissioning and startup. And this formula, as I mentioned before, it's based on the International Water Quality Association, and the background of this modeling was used BOD. What we changed or we revised the mathematical modeling using the soluble phosphorus and detention time, and finally we didn't find no significant difference used the COD, but it will give good results. But using the BOD, we'll find a significant difference, and this will become the major, not wrong, but the major defect in using the traditional formula. And this is the empirical mathematical model which can use for designing such modeling technique. Finally, this is the semi-empirical model which was used, and what is the limits of calibration of the model which was used in the International Station Water Quality, and the PNR model can be adapted and customized or revised, and you will find this new updated formula. And finally, this is the spreadsheet program which can use for sizing of the reactor and to differentiate the different stages of the process treatment, and it will give you the efficiency. Comparing the results, you will find that the experimental data obtained from field measurements, from any actual plant, and from the experimental model, just to verify or to validate the results from this experimental modeling and the formula and any actual plant. We make three categories: one from actual plant under operation, use the same technique, and compare the result obtained of the effluent quality from this plant with our experimental model results obtained, and also on the same time with the theoretical values obtained from the mathematical derivation used the formula which have been mentioned before. Conclusion: simple COD fraction method was developed for this study, and it is a reliable method. The kinetic parameters you can use for any PNR model or biological nutrient removal model. Those kinds of feasibility study is very effective and efficient for phosphorus removal, and this will match and comply with the constraints on standardization of presidency and meteorological environment, PME, which require the municipal wastewater treatment plant in Saudi Arabia for final discharge to the Red Sea or Gulf to reach an optimum value of effluent phosphate less than 2 or within 1 milligram, which was very difficult to reach before with chemical traditional methods. And finally, we will have the PPR test, which if you don't have the model, you can use a very simple test and cheap one that you can also predict your value, which you like to build your treatment plan based on 2 hours anaerobic detention time. So you can use a model, you can use the formula, you can use a simple test in actual plant. So if any plant now under operation, you can change the process in this plant to achieve the process removal for phosphate, and then you can grow the PEO or phosphorus accumulating organism from the return sludge to the anaerobic stage and mix with the raw sewage, and finally your mixed liquor suspended solids will have a certain biomass efficient for removing those phosphorus or uptake those phosphate PO4 as a phosphorus in the aerobic stage, or what's called oxide stage. And using this predicting model, you can also define what is the size of your reactor based on the detention time T, and also based on the actual COD value obtained from the sampling analysis. Finally, you will have that in Randall in 1992 shows our BOD, but now in 2007 you can shows that the COD is more efficient, and instead of using the International Association Water Quality Modeling, we can develop a simple model updated using the COD fraction, which is 40% from the total COD, and then this simple test also can be used for any actual treatment plant under operation for evaluate the efficiency or the feasibility of using this one, and to match with PME in KSA Kingdom of Saudi Arabia, which is our main concern, that to develop such treatment plants in compliance with the standard regulations and to protect our water courses as a Arabian Gulf or Red Sea, and also to have optimum ratio of such efficiency, and by transferring a new technique can enhance the traditional methods used by such OEMs using this what's called dynamic simulation. And this is to finally, this is the training which have been done in such to transfer the technology from Germany to Saudi Arabia. What we have changed, that we adapt our model within the environmental conditions in Saudi Arabia. So it means that using in chemical precipitation in Germany was reached optimum value 0.42. Now we reach it about 1 milligram per liter or 1.4.